I will clear this terminal a little bit and escape my environment. So yes, we will see how to run Julia in batch mode. We have seen how to start Julia on the command line, yes, with the Julia command. But here we can run only lightweight things, yes, uh, such as testing some printing option or maybe some plotting. But if you want to run code, yes, which takes longer than 1, 2 seconds, then we need to submit the job to the queue. And this is similar for all the three languages, R, Python, Julia, right? So instead of submitting the job here on the login node, we need to create a batch script and submit the job to the Slurm queue. Here are the projects, yes, especially for Kebnekaise. This is the one that you can use for this course. This is the project directory that you may have seen previously. So the Slurm, I don't know if you were in the previous lectures yesterday and in Monday. So we talk about the Slurm scheduler, which keeps track of the available resources, enforces local system resource usage, and scheduling policies, and manages the job queue. So this Slurm scheduler is the same for the Swedish clusters like HPC2N, UPPMAX, LUNARC, PDC, and NSC. However, there are some details, yes, in the supported options at the different centers that need to be taken into account, right, when you submit a file. So it's not the case that you take one submit the script from HPC to N and then you directly can use it to UPMAX, for instance, or for LUNARC or PDC. Because although the general structure is the same, yes, the details can differ. And the best place to look at the submit files for each center is at the different documentation pages for each center. So what is the workflow? We can write a batch script, yes, a batch file as we have seen in the previous day, if you were there. And then here you specify the modules that you need. Yes, also the possible isolated environments that we have studied today. And you can also allocate the resources that you want. For instance, if you need the CPUs or GPUs or even large memory nodes. And once you have this file script, you submit the job with the sbatch command, and this is the batch script, right? Which contains a reference to your Julia script that you want to execute. So this ending.sh is not necessary. You can put anything you want. It's not like in Windows where you need some ending. Then here you can, I wrote the .sh, but you can also write .batch. It's not necessary. You can leave it also without any uh, ending. Yeah? So some commands that you can use for monitoring the batch system is here sbatch and the name of your job script. This will submit the job. If you want to see the jobs that you are running, you can type SQ-U and your username. For instance, here you can type SQ dash U and my username. Yeah. And this will list the jobs that I have on the queue. For instance, here this will list all the jobs that I have on the queue. Yeah. Or there is a shortcut that you can use, the SQ dash dash me, which means myself. If you want to check more statistics on your job, you can use the S control show job and the job ID. And this job ID is the number that you get when you submit the batch job with this batch. If you want to cancel the job, is cancel and the job ID. And also other types of statistics can be obtained with this command SACCT and with these options. So this is a nice feature that is available on NAISS. And here you type on the command line job usage and the job ID, the number that you got from each batch. And this will give you a link, a URL that you can paste on your local browser. For instance, here in my local browser, and then you can see the statistics once the job starts running. So here there is one example that you can use for Julia. This is some simple Julia script. So let me see if I have it already. No. So I don't have this script. So I can copy this content, then I paste it in the file, which is called Julia script. And for HPC2N, we can use the following template, which I can copy. I can call it, for instance, job.sh, in case I don't have it, but I have it already. Let me see. I can call it VIM, job serial.sh. And here I can modify some variables. I need to write the project name, the project ID for this course. This is the name of the script. And here is the time that it takes on the queue. This is the number of tasks that I will use. And because this is a serial job, I will use only one task. And this is the error file, the output file. Here we recommend to add this line, which is a purging line for disallowing any modules that you may have loaded on the terminal. And here there is a Julia module that I will use. It's 1.8.5. And here is the line that I use to run this script. So I will add something here just to show you how the job usage works. I will use some sleep. Let me see. I will try this. Okay. The last line is not necessary for Julia, but I just want to show you how the job usage command works. Yeah? So that's why I am writing sleep and some number of seconds. So now I have the script and I can submit it. And this is the job ID that I mentioned previously. Yeah? So once the job starts running, you see that it is running, it is here. Yeah. I can take this number on the command line, I write job usage, and this gives me an URL, and I can use this on my local browser. And here, after some minutes, I will see the statistics of the job. So if you are using CPUs, it will show you the CPU utilization and memory, and also if you're using GPUs, you will see the usage of the GPUs. So we have seen how to create an environment, and in this case, you can create another environment, or you can use the one that we did previously, where we installed the package DFTK. And in this case, I show you how to start the job, but by using an environment. So for instance, remember that we created an environment called my first M. Then in this case, I am in the folder that contains the environment, right? And here I can create my script. Yeah. Here, and then I modify the project name. So the serial environment contains only the status of the environment. Let me see if I have it. Yes, I have these lines already in the Julia script. I already have the job. And notice here that this line will activate the environment that is in the current directory. Yeah. So I can type batch job serial. Then I can check. So you can see here, these are the output files and the error files. And we can take a look at this one. Okay. So this, I see why, let me see. I am getting this error. Mhm. Oh yeah, I see. And this is related. You can see that here I get this error. You shouldn't see that. And this is because previously, if you remember, I emptied the standard libraries for Julia. So you can see here, if I do load path, then I can see that only the current environment is there. So if I want to recover these full three environments, I need to push all of them. Let me see. Or even I can use this one. Let me see. This is a bit more elaborated. I will add this one. Uh, the default environment, this one. Oops. And the standard library. Okay, so now if I start Julia and I load the path, you see that the three environments are there. Yeah. And so that's why I mentioned that this is more elaborated, and you don't need to modify the path to the environments. Just leave them there, and Julia will take care of the stack environments. Now, if I submit the job again, I would expect you to avoid this situation. Now you can see that now the output is printed out. And you can see now the status. Yes, that this was the goal, yes, in this part of the simulation to get the status. So with that part with the load path is more specific, and as I said, if you don't need to be too strict with the environments that you want to consider in your Julia session, Julia will take care of these parts. Yes. So in the case of the parallel code, there are several tools that Julia offers. One of them is the threaded package, yes, uh, where you can do the shared programming, and also the distributed packages for distributed programming that I will mention after the launch. Yeah. But first of all, uh, now for these two packages, you don't need to do any installation because they are already included in the base Julia installation, in the base library. But if you want to use another package like MPI, just for distributed computing as well, then you need to follow these settings, yes, in Julia. So first of all, load the module for the tool chain containing the MPI library. Then load Julia, the Julia version that you want. I choose this one, 1.8.5. Then start Julia on the command line and add the MPI package. So after you have done this, start the MPI package on Julia and run this script. So this will give you the path where the binary is located, and then you can add this path either in your bash RC file or in the batch script. Yeah. So here there are some examples for the parallel jobs. This is a serial job that will use one single core, and these three are for parallelized codes. This is by using the threaded programming. This is the distributed programming, and this is MPI programming. So how to run these codes? So for the serial case and HPC2N, you can find the templates here. Here you can see the templates for the serial job. Yes, here you can use only one core or one task. For the threaded programming, you can specify the number of threads here, and then the number of threads should match the one that you write here. Yeah? In this case, I am using 8 threads and 8 threads. Distributed programming is also 8 tasks, and also you start the script with 8 tasks. This command is optional, it's not mandatory. I just want to time the code by using different number of CPUs. And in the case of MPI, so you also need to load the tool chain where MPI was included. And here you add the path that was given by Julia when you execute the MPI exec script. And then you use this command here. Then start the job with 8 MPI ranks, and this number is the same as this one. In the case of GPU codes, yes, Julia can recognize the NVIDIA GPUs and also the AMD GPUs. So notice that at HPC2N we have also an AMD GPUs, and you can use that in your Julia. So how to use that? In the case of the CUDA code, start Julia and then load the CUDA module, and then in the package mode, add the CUDA package. So then for HPC2N, so you can use this simple script where you take some arrays and you perform some multiplications, matrix multiplications on the CPUs and on the GPUs. This is by using NVIDIA GPUs. Then you can see here the script. So the new option is the -GRES GPUs. And this is the type of the GPU card. In this case is a V100. And I want to request one card only. But also it's possible to use the AMD GPUs at HPC2N. And the way to do that is by going to the same manner as in the PDC. So first you load the Julia module, and then you will need to install to load some ROC AM module. Yes. So if you want to run this setup on HPC2N, just let me know because I need to add this line for the AMD GPU. And for the AMD GPU, this is the script. Instead of CUDA, you add the AMD module, and instead of the CUDA arrays, you load the ROC arrays. Yeah. So this part is more specific and is related to cluster managers. And this can give you more interactivity in your workflow. So here you start a Julia session. You will need to install this cluster manager in PKJ. Yeah. And then here you start in the interactive mode. So you start adding some processes. This is your project ID. And here you request the number of cores that you want and the time. So instead of writing a batch script, you can do this, right? So this will give you some number of cores, in this case 2. And here you can write your code that can run in parallel mode. But this is more specific in case you want more interactivity. So we have 2 examples for this. Yes, and one is a bonus example for exercise for running a machine learning job. And this is more elaborated. It requires you to download some database, as it is mentioned here, but also it's more realistic. Do you have any questions before the launch?